Hi chemistry students. Today we're going to be doing an example of a limiting reactants problem. This one's going to be a little bit tougher than our normal ones because we're actually going to find out how much of our excess reagent we have left over. Alright, so our reaction here, we have C2H2, that's a gas, it's combustible. You'll notice this is a classic combustion reaction. It combines with oxygen, forms carbon dioxide and water. For this problem, you have 10 grams of C2H2, so we might as well just fill that right into our equation here. We have 10 grams of C2H2, and then we have 15 grams of oxygen reacting together. So the question asks how many grams of carbon dioxide are produced, and then how many grams of the excess reagent remain at the end of the reaction. So there's actually kind of two parts to the problem. The first part of the problem is just like any standard limiting reactants problem. So what we need to do is two stoichiometry problems. If you have 10 grams of C2H2, you're going to have to find out how many grams of carbon dioxide you can produce. So you're going to start off by finding a molar mass, 26.04 grams C2H2 to 1 mole C2H2. Use your coefficients from your balanced equation. And then your molar mass for carbon dioxide. To try and find out how much carbon dioxide you can produce. So you have enough of the C2H2 to produce 33.8 grams of CO2. Now, we also have to consider oxygen. Maybe we run out of that first. So 15 grams of oxygen. Alright, so let's find out our carbon dioxide again. So 32 grams of oxygen. Goes to 1 mole of oxygen. Our molar ratios. And find out how much carbon dioxide we have. So it turns out we have enough of our oxygen to produce 16.5 grams of carbon dioxide. So in this case, for our problem, our amount of carbon dioxide we can actually produce is these 16.5 grams, because at that point we run out of oxygen, then you can't produce any more carbon dioxide. So we can actually produce 16.5 grams of carbon dioxide. So our limiting reagent is oxygen, and our excess reagent is C2H2. So the next part of the problem asks how much of your excess reagent remains at the end of the reaction. So we're trying to find out, we know our excess reagent is going to be the C2H2. So the question is how much of that remains? Well, so the way that I'm going to answer that question is we can calculate how much of the C2H2 we used to produce 16.5 grams of carbon dioxide. And there's two ways that you could do this. You could either use the 16.5 grams of carbon dioxide and solve for how many grams of C2H2 it takes to do this, or you could take the 10 grams of C2H2, or wait, nope, not that one, the 15 grams of oxygen, rather, and find out how much C2H2 you need. So I'm going to do the second one. I'm going to use this value here. So what I'm going to do is I'm going to take 15 grams of oxygen and find out how much of the C2H2 I need in order to use up all of that. So I'm going to just do a stoich problem. So if I go from grams of oxygen to grams of C2H2, it'll tell me how much of the C2H2 I use in that reaction. So we're going to keep going through here. So what we find by doing this is we're going to find out that you need 4.88 grams of your C2H2 in order to get your 16.5 grams of carbon dioxide, or in order to use up all of the 15 grams of oxygen. Well, so if this is how much we used, and we started with 10 grams. Now to find out how much is left over is you're going to find the difference between those. So 10 grams minus 4.88 grams is going to be equal to 5.12 grams. So if you're trying to find out how much of your excess reagent is left over, your excess reagent is the C2H2. And this will tell you how much of the C2H2 is left over. So you have to kind of work backwards. There are two starting spots, again, that you could have started. I'll try to erase the one right here with the gram C2H2. You could either start from 15 grams of oxygen, which was your limiting reagent, and that's what I did here in the problem. You could also start at your product and find out how many grams of the C2H2. Either one, you should get to the same answer at the end right here.